Hello students. Today we are going to discuss about one of the important techniques in the numerical methods, that is Runge Kutta method of fourth order, or in short form we call it as RK method of fourth order. So this method will be used to solve a differential equations with conditions, especially initial condition. Okay. So this is a very important technique which is used to find the solution for the differential equation with condition. Now I am taking one simple differential equation. Let me take, let dy by dx equals to f of x comma y with the initial condition y of x naught equal to y naught. Now here we have the differential equation dy by dx, and this y of x naught equal to y naught is the condition. Usually there are two types of conditions. One is initial value, another one is boundary value. Initial value conditions, boundary value conditions. Any problem with initial conditions, they are called initial value problems. Any problem with boundary conditions, they are called boundary value problem. So what is initial value condition or initial condition? What is boundary conditions? Let me take a small time to explain that. Suppose if I have a function like I have a function f of x or f of x comma y. If the function is defined like here y of x naught, y of x1, y of x2, y of x3, etc. I'll just take this as, instead of x1, x2, x3, everywhere x0, x0, x0. This is y dash, this is y double dash, this is y triple dash, etc. Now you can see the difference between the conditions. What is the difference between the condition? Here the function y is called function. Function, its derivative, its derivative, its derivative. A function and its all derivatives are defined at the same point, that is x naught, or usually we call it as initial point. A function and its derivatives are defined at the same point or initial point, then such conditions are called initial conditions. And the problem with initial condition, call it as initial value problem. Now when it comes to boundary conditions, y of x naught and y dash of x1, y double dash of x2, etc. Now you see the function and its derivatives are defined at more than one point, or they are defined at the different points. You see y is defined at x0, but y dash is defined at x1, y double dash is defined at x2. Then such conditions are called boundary conditions, and any problem with boundary condition is called boundary value problem. I hope it is clear, dear students. You see the difference between both the conditions. Here the function and its derivatives are defined at the same point, therefore they are called initial conditions, and the function and its derivatives are defined at what? Different points or more than one point. Then such conditions are called boundary conditions. And the problem with initial condition is called initial value problem, and the problem with boundary conditions are called boundary value problem. Now here we are discussing the solution of the differential equation with the initial condition using RK method of fourth order. So now what exactly this method states? I have a simple differential equation here, dy by dx equal to f of x comma y, and y of x naught equal to y naught. Now we are supposed to find out y of x naught plus h. We are supposed to find out y of x naught plus h. See, y is defined at x naught. X naught is usually the starting point. Let me show you here one line. This is x naught. X naught plus h means definitely some next point of x naught. There this h indicates some increment or decrement, usually increment. Now we are finding the next value of the function at that particular point, that is x naught plus h. So what RK method of fourth order says, here it is y naught plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4. Okay, y of, see, you see x naught is here, we have the function y of x naught and this is our initial conditions. Now we are finding the function value y at this particular point x naught plus h, and this function value we are finding using RK method of fourth order. So what is RK method of fourth order states? Y naught plus 1 by 6 into k1 plus 2 k2 plus 2 k3 plus k4. Here all these k1, k2, k3, k4 are constants to be determined. We are supposed to find out all these constants by using simple formula. So what are those formulae? First we have to find out k1 using the formula h into f of x naught comma y naught. k1 h into f of x naught comma y naught. Then k2. So what k2 says? h into f of x naught plus h by 2 comma y naught plus k1 by 2. And if I want to find out k3, so k3 is h into f of x naught plus h by 2 comma y naught plus k2 by 2. Then k4, that is h into f of x naught plus h comma y naught plus k3. You see, all this acts like iterative values, means recursive values. So if k1 is proper, then we can easily find out correct value of k2 because k1 is used in k2. If k2 is correct, then k3. k3 is correct, then k4. That's why the initial value, the first value of k is very, very important. How to find out this k1, k2, k3, k4 in the RK method is very important. So once we got k1, k2, k3, k4, if we replace all the values in this formula, then we will get the required value of that function at that particular point. Okay. So once again, remember, RK method of fourth order is used to find the differential equation, especially with initial conditions. And what it says, y of x naught plus h equal to y naught plus 1 by 6 into k1 plus 2 k2 plus 2 k3 plus k4, where all these k1, k2, k3, k4 are constants to be determined by using this formula. k1 is nothing but h into f of x naught comma y naught. k2 is nothing but h into f of x naught plus h by 2 comma y naught plus k1 by 2. k3 is nothing but h into f of x naught plus h by 2 y naught plus k2 by 2. k4 is nothing but h into f of x naught plus h comma y naught plus k3. Here these methods are very important because most of the students will do the mistakes here only. You have to write at least 4 or 5 times the formula and practice it properly, because here everywhere it is comma. So in a hurry burry way in the exam you may write plus here or multiplication here. That will become biggest mistake in the problem. Okay, that is the reason practice the formula 4 or 5 times properly, write and practice. Do not make any mistake while writing the formula, because as I said, all these are depending on each other. So k1 is very important to find out k2, k2 is very important to find out k3, k3 is very important to find out k4. That is the reason. So let me take one simple example to operate RK method of fourth order. We will discuss that. Pause it. We will discuss one example. Let me take one simple differential equation. dy by dx equals to 3x plus y by 2. Given condition is y of 0 equal to 1. Compute y of 0.2 is what? Using RK method of fourth order. Okay. So first, what is our important step here? We have to write the given detail properly. So dy by dx is nothing but what? dy by dx is nothing but our function, that is f of x comma y. f of x comma y is what? 3x plus y by 2. and the condition what they have given, y of 0. So y of 0 equal to 1. So what is the meaning of this condition? Y value is 1 at x equal to 0. Y value is 1 at x equal to 0. So this value is nothing but y naught. This value is nothing but what? X naught. So x naught value is 0, y naught value is 1. Why? Because how we will write usually function? Y of x. Okay. Y of 0 means y of x naught. Y of x naught means y naught value is 1, x naught value is 0. And usually h will be given in the problem. If they are not given, you just find it from this given statement. So if I show you here, they are giving y of 0 means x value is 0, corresponding y value they have given. And they are asking what? Y of x naught plus h means this value. So what is that? Y of 0.2. So this 0.2 we have to find out. Now what is the difference between 0 and 0.2? That is our h. So what is that? H value is 0.2. The difference between this. Okay, or you have x naught plus h equal to x1. Okay, the next value I am taking x1. So x naught plus h is x1 means x naught value we know, x1 value we know. X naught value is how much? 0. H value I don't know. X1 value is how much? That is estimating value. They have only given 0.2. So h equal to 0.2 minus 0 is 0.2. This is another way to find out h value. But usually I have to follow the first graphical straight line method. Very simple. So these are all prerequisites for our problem. So the next step is we have to find out K1. We already know K1 formula. H into f of x naught comma y naught. This is very important. Everybody should understand it properly. H we know. What is h value? From here we got it 0.2. And f of x naught comma y naught. Here f of x comma y we have 3x plus y by 2. X naught comma y naught means here I have to replace x by x naught, y by y naught. That is 3x naught plus y naught by 2. This is only for understanding purpose I am writing. Once you well versed with problem, you directly replace x naught y naught value in the problem. Okay. So that is K1 equal to 0.2 into 3 x naught. X naught value is what here? 0 plus y naught. Y naught value is what? 1 here. So 1 by 2. Y naught by 2. So if we simplify that, then we will have K1 value. So what is that K1 value? 0.5 into 0.2. So K1 value is what? 0.1. This is very important step. I will repeat this. K1 equal to h into f of x naught comma y naught. H value is 0.2. This f of x naught y naught how I replaced? Because I know f of xy here. F of xy value is what? 3x plus y by 2. So there we have x naught y naught. Therefore I am supposed to replace x by x naught, y by y naught. So x by x naught, y by y naught. 3x naught plus y naught by 2. We know x naught and y naught value. If you replace and if you find, you will get K1 value. So K1 value is what? 0.1. Then K2. So here I will write answers directly because there is no calculator to find out everything here. So you just follow the procedure and calculate using calculator. As per the procedure you will get the answers. Okay. So what is K2? K2 is h into f of x naught plus h by 2 comma y naught plus K1 by 2. Here comma is there, you have to remember. So K2 equal to h is what? 0.2. Before substituting in f of x comma y, first we have to simplify. This we have to make it in the form of f of x comma y. Then you have to replace. X naught is how much? X naught is 0. H is how much? 0.2. So 0 plus 0.2 by 2 comma y naught. Y naught value is how much? 1 plus K1. K1 is how much? That is 0.1. So 0.1 by 2. Now this K2 becomes what? F of 0 plus 0.2 by 2 is 0.1, comma 1 plus 0.1 by 2. If you simplify that, that is 0.5 by 2. So totally you replace this 1 plus 0.1 by 2. So now this is our x value, this is our y value. If we replace that value in the function, then we will have this answer is what? 1 plus 0.1 by 2 is 1.05. Okay. So this is our x and y value. If I replace in K2 equal to, here h I forgotten, you just write h 0.2. So that is 0.2 into 3x0. 3x0 value is what? 0.1 plus y0 by 2. Y0 value is what? 1.05 by 2. So if we simplify this, so we will have K2. So the K2 answer is 0.165. 0.165. I'll repeat. The K2 is again once again h into f of x0 plus h by 2, comma y0 plus k1 by 2. H value we will have here, I am replacing f x0 is 0 plus h by 2 I have written, y0 is 1 plus k1 by 2 I have written, h 0.2. If we simplify this 0.2 by 2 is 0.1, 1 plus 0.1 by 2 is 1.05. Now this is our x value, this is our y value. These two values I am supposed to replace in f of x comma y, because that is our function. So function is 3 into x0, 0.1 plus y by 2, 1.05 by 2. If we simplify, we will have K2 value. Okay. So now we have to find out K3. So this is again same procedure is same. So I am requesting you all kindly understand the procedure properly, because there is no use of solving more number of problems without knowing the procedure or without understanding the procedure properly. So now we have to find out the next value, K3. So what K3 says, K3, again the formula is K3 equal to h into f of x0 plus h by 2, comma y0 plus k2 by 2. So here finding x and y values is very important. Then we have to replace in the function. K3 equal to h value is what? 0.2. F of x0 is 0 plus h is 0.2 by 2, comma y0 is 1. They have given. Then K2 we find it as 0.165. 0.165 divided by 2. So if we simplify these two, we will have x and y values. So K3 equal to 0.2 f of, this again 0.2 by 2 is 0.1, comma 1 plus 1 plus 0.165 by 2. If we simplify that, we will have other 2 points as f of 0.1, comma 1.0825. Now these are our x and y values. So K3 equal to 0.2 f of x comma y, we have defined function. This is our f of x comma y. So there we have to replace 3x, x value is how much? 0.1 plus y by 2, y value is how much? 1.0825 by 2. So if we simplify, we will have K3 value. So K3 equals to 0.16825. 0.16825. See, since it is a numerical technique, having 4 decimal values is very important, or it's better to take at least 4 decimal places because it is numerical technique, approximate answers we are doing. You can take 3 decimals also, no problem, but usually we will prefer at least 4 decimals. More than 4 also you can take it. Okay. So K3 is 0.16825. Next we have to find out K4. K4 formula we have h into f of x0 plus h comma y0 plus K3. So if we replace all the values here, 0.2h, f of x0 is 0, h is 0.2, comma y0 plus is 1, plus K3 we have obtained here 0.16825, that you are right, 0.16825, and if we simplify this, K4 equal to 0.2 into, so we are finding, we are getting only x and y values. So 0 plus 0.2 is what? 0.2, comma 1 plus 0.16825. If we simplify that, then we will have the points as 1.16825. 1.16825. Now this is our x and y values. So this we have to replace in f of x comma y. So 3, x value is 0.2 plus y is 1.16825 divided by 2, y by 2. So if we do it, we will have K4. So K4 answer is 0.23682. 0.236825. Here I am writing directly from the book because I do not have time to use calculator. You people use calculator, scientific calculator or normal calculator and simplify it. So K4 value you will get it. So we got K1, K2, K3, K4 all the values. Then we have to replace in the general formula what we have written in the beginning. So I will write that formula once again and I will replace all the values once again in the formula. Okay. So we have written in the beginning y of x0 plus h, that is y0 plus 1 by 6 k1 plus 2 k2 plus 2 k3 plus k4. So you just replace all the values. Y0, so y0 we have written in the beginning, that is 1 plus 1 by 6. K1 we got it as 0.1 plus 2 K2 we got it as 0.165 plus 2 K3 we got it as 0.16825 plus K4 we got it as 0.2368 0.236825. So again, using scientific calculator, if you do it, you will have y of 0.2 value as 1.1672208. This is the value of y of 0.2. As I said in the beginning, since it is a numerical technique, if you take more number of decimal values, that much approximate answers you are getting. But if you take only 4 decimals also, that is 1.1672, that is also correct. So this is overall the problem using Runge method. So what we have done, we have a differential equation dy by dx. They have given initial value y of x0. We are finding, or we got the next value of this function or this differential equation at this point. Okay, this is the use of RK method of fourth order. I hope you enjoyed. For any doubts and queries, you can put the comments also. So thank you very much for watching this particular problem. We'll meet in the next session.